I'm Simon Butler and I work in the Software Systems Research Group at the University of Skövde in Sweden. I'm going to talk about ongoing work to create an Internet of Things demonstration using open hardware and open source software. Open source software and open hardware provide industry with opportunities to develop tools and products more rapidly by building on or adapting existing implementations. We are using off-the-shelf hardware and software components to implement a sensor network that is intended to demonstrate interoperability between different open hardware IoT platforms using open source software and the practicality of constructing IoT sensor networks using open hardware and open source software components. Briefly, the system consists of three main elements: a system that will be on display, some remote sensor devices, two are being implemented, more are planned, and a server in the cloud that communicates between the remote sensors and the displayed system. The remote systems and one item on display are functionally similar sensor units with custom circuit boards that gather temperature, air pressure, humidity and light level data. The data is transmitted using the lightweight machine-to-machine protocol to a server running on the BeagleBone Black microprocessor. Another microprocessor is used to display information for visitors, and a couple of motion detecting devices also provide data that can weight the information display. All the microprocessors and microcontrollers used are Open Source Hardware Association certified. The two microprocessors use ARM processors and run Linux. The MCUs were chosen because they're capable of running an OSS operating systems such as ARM Mbed, Free Real-Time OS or Zephyr. Software development is simplified as a consequence of using an OS because no bare metal programming is required. It's also easier to try to use the Wacom LWM2M client with an operating system. Sensors were selected as, quotes, available components. This is a definition taken from the CERN Open Hardware license. So essentially the hardware can be used without restriction, and any software required to use the hardware is available. There is separate tooling for each embedded operating system. Usually this is constrained to a build system and libraries. Some systems also have integrated development environments which require additional learning. And some tooling is also needed to load software onto an MCU and to support debugging through reading serial outputs. Sometimes this is as simple as using a USB cable. At other times it can be more difficult, requiring the use of specific cables or hardware programmers. Another problem area has been the manufacturer's hardware implementations that use older software revisions. One consequence experienced with the ESP32 board that I used is that online documentation and information is unhelpful and example code won't work. Older documentation has to be retrieved from version control and the examples available are much less common. Software licensing was also problematic at times. If we go back to the idea of an available component, we need both hardware and software available for it to be used. Some components libraries available were only licensed as public domain, which makes them not open source in Europe. More recent software is also licensed as CC0, a no rights reserved license, which makes it open source software in Europe. And in one case, a non-open license was used where the author unhelpfully stated no derivative works in their license. The consequences for us were that some components were not used because there was no open software to support their use, and we didn't have time to develop the software ourselves, although for an industrial application that may well be a solution. So, in conclusion, the lessons learned were really that design requires a lot of care, potentially multiple iterations to identify and document all the issues in the hardware and software bills of materials, but also in the tooling that's required. And that hardware components may be unavailable simply because of small amounts of software licensing and issues. And it's not just licensing itself, it's licensing and its relationship to how you intend to license your product. So real world lessons: reduce complexity in designs, keep the variety of hardware used small, and limit the number of software development platforms required. Thank you for listening.